In this video, we'll discuss the binomial distribution. What binomial distribution does is it studies the repeated independent trials in random events. You see this a lot in tossing a coin or rolling a dice. In the example here, if you toss a coin 4 times, I will give you $1 if you get 2 heads, otherwise you will give me $1. Being rational, should you play the game with me or not? Assuming the probability of tossing a head is half and the probability of tossing a tail is also half. In this example, the repeated independent trials are getting 2 heads and the random events are 4 tosses. What this question really asks is, what's the probability of getting 2 heads when you're tossing the coin 4 times? If it's greater than half, then you should play the game with me. If it's less than half, you should not play the game with me. Let's solve the problem using the laborious way first. So the laborious approach. The most straightforward way is to write out all the possible outcomes. For example, if we are having all heads, we'll have 4 tosses like that. If we have 3 heads, then there are a few possibilities. We can have tail, head, 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 or head, tail, head, head, then head, head, tail, head, and head, 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 tail. We can also have 2 heads, 1 head, and a 0 head. I'll just write down all the possible outcomes. Let's look at the outcomes. To have all heads, we only have 1 outcome. To have 3 heads, we have 4. 2 heads, we have 6. Then 1 head, that's 4. And 0 head is 1. So in total, we have 16 possible outcomes. The question is, what is the probability of having 2 heads? That's simply 6 over 16, which is equal to 3 over 8. 3 over 8 is less than 0.5. Therefore, you should not play the game with me, because in the long term, you will lose money. This is a very laborious way to solve these kind of questions. What if I ask you toss a coin for 10 times and I give you $1 if you get 5 heads? Otherwise, you will give me $1. Will you play the game or not? Then the table we drew up here will expand to a very large size. What we can do is we can use the binomial distribution equation or binomial distribution formula to solve this type of problems. So the formula writes in this way: the probability of some repeated events is equal to combination of n s p s q n minus s. Let's look at what n, s, p, and q stand for. N denotes the total number of the events. So you toss the coin 4 times, so n is equal to 4. S is how many times to achieve a specific event. You want to know having 2 heads, so S is equal to 2. P denotes the probability of getting head, or the probability of the specific event you're looking for. This is half. And also Q is the probability of not getting the specific event. It's also half. We can just plug in all the numbers. The probability of having 2 heads is equal to bracket 4 and 2, then half 2, half 4 minus 2. There's a formula to expand the combination. If we have n and s, it is written as n factorial, s factorial, n minus s factorial. We can further expand what we had above into p 2 heads equals to n is equal to 4, so that's 4 factorial. Then s is equal to 2, 2 factorial, 4 minus 2 factorial, then half square and half square. 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1. 2 factorial simply 2 multiplied by 1. Then 4 minus 2 is 2. 2 factorial is 2 multiplied by 1. So these can be cancelled out. Half square is a quarter, so it's 1 over 4. Half square is a quarter, again it's 1 over 4. 4 and 4 can be crossed out. So in total, we only have 3 in the numerator and 2 and 4 in the denominator. So 8 over 3. That's the same answer we had from the laborious approach. In the next video, we'll look at a special case of binomial distribution called Poisson distribution.